Okay, now we got it going. Okay, so today's review, so we're going to go over page by page through your paper packet. Those that are online, you need to print that. That is in week 14 in your online stuff, if that's where you happen to be. It's just a little easier to go through this one than to do the Hawks one, because the Hawks one changes numbers, and this one's consistent, so we know what numbers we have with this sheet, and so we can work these guys out. So anything on page 1 that we need to go over that you guys had for problems in this one? And if you notice in here, there's about 3 questions that end up relating to each other, like here's a plus, and here's a plus, and here's a plus. Here's just plain straight ones we need to cancel and to reduce. And then there's multiplication, subtraction, complex fractions. All of these are a sample of each kind of problem that's on your final exam. So realize that each chapter has about 5 questions to your final exam outside of functions, and functions have been throughout, and so that makes up the other part that we happen to have with that. So if you're able to do these problems, then you should be able to do your final exam and do quite well on it. And it goes for every piece that we go through in here for your different sections and your different pieces. So anything on this page that you think we need to take a look at, we need to go through. Now, if you have not worked on this, now's kind of the time to say, okay, that one looks like it's something that I need to have some help with. Because when you go home, again, it's determining what you guys want to do. If we get a good review today, then we'll do your exam on Monday. But if you want, we can hold that off and do your exam on Wednesday next week. So we'll see where we end up at when we get all done with this. So I think what I'm going to do, if you guys don't have any questions on this first page, just so that the people out there who might be watching this know, I'm going to just kind of hit on one of each of these different varieties in here so that we have at least one that you can do that's connected to those. So if we look at the first one up here, it says find the restricted values. We've had restricted values throughout basically this class. They hit in different varieties in different places. What that means is your denominator in here, this piece, can never equal 0. So if it equals 0, we've got a problem. So what we need to do is factor this, and then we got to find out what those 2 values are that cause this thing to become 0. So in here, we're going to factor it. So factors of a -8 that give me a -2 when I'm all done. What would those be? You got an idea? -4 and a +2, yes. So then if I set each of these equal to 0, I'm going to find out that x can never equal a -2, because I got to subtract 2 here. And if I do this one, I'm going to add 4. So x could never also equal a +4. Because if I put those numbers in here, my answer is going to become 0, and I can't have 0 for the bottom. So that's what happens with that part. If you had just a straight number down here with nothing else, we had some of those in this last chapter we dealt with. In chapter 11, we had restrictions too with that one. So you have to be careful with those. So here again with this one, same kind of thing. This one gives us a +2 in the middle. It still factors basically the same way. It's just your pieces are going to change in there. Okay? So you got the idea with those type of problems? Again, you're going to run across one of those, so be aware what that restriction stuff means. And then problems 4 and 7 and 8 are all addition of these things. So to add them, we have to have common denominators. So I need another sheet of paper because I know I can't fit my whole problem in there. So do you have one of those that you think is tougher than the other ones? I think actually number 4 is probably the harder one of all of them that we end up having to do, because some of these already have their pieces factored on one side. So we'll take a look at number 4. So in number 4, we have xy all over x squared plus 11x plus 24 plus x over 2x squared plus x minus 15. And since chapter 7 was all factoring, we need to do that same kind of thing here. So I have xy. If I factor my bottom piece, I find I have an x and x. Factors of 24 that add to 11. What would they be? 8 and 3. So plus 8 plus 3. Okay. Is it a 5? Oh, it's a division. Okay. But we'll still take a look at what we got to do with it. We still got to do a division anyway. So we got a division in there, looking at it. So then, same thing happens is I still need to factor this, but because it's division, the second one inverts, but I still have to factor this piece and figure out what it's going to be. And that's where we need to go to that long drawn out piece to figure out what this thing factors to. So first term times last term is a negative 30x squared. So things that multiply to give me that, but at the same time add to give me just a single x in the center. So I think we know that's going to be a positive or negative 5x times a positive 6x. And negative 5x plus 6x gives me x. So then replace my middle. And group in twos. Factor what comes out. The first one, I can take only an x out. The second one, I can pull out a 3. And so the two factors that I put in here are going to be 2x minus 5 and x plus 3. And so then I go back through and cancel anything that can cancel. So what stuff cancels? Well, this x will cancel with this x. This x plus 3 cancels with that x plus 3. And so what we end up being left with is y times 2x minus 5 all over x plus 8. And that's what it becomes for my answer to that one. Okay, so this became y times 2x minus 5 all over x plus 8. Okay, that makes sense? Again, we got to invert it, so we need to make sure that we do that part to it. The multiplication ones that are in here, this one's a multiplication, this one's a multiplication. So you're going to have something on that order that will be in there. Because remember in chapter 7, we did adding, subtracting, multiplying, and dividing. So if there's only 5 questions from chapter 7, that means probably one of each of those will be in there. Okay, so that's the thing to do. So I think probably out of the harder ones that are in these two, probably number 6. And again, if you've worked on these, let me know if there's a certain one on that page that we need to work out. So let's see if we can work out number 6 and see what happens with it. So I'm going to write it down here on my paper. And we need to see if we can factor this to see if I can come up with solutions, so that with multiplication, again, you're looking for items in the numerator that cancel with items in the denominator. So if I take a look at this, it's a kind of a 4-step process because I got to factor each piece as I go. So this piece, x plus 2 doesn't factor, but I need to factor this part. So 2x times a negative 15 is again my negative 30x squared. But this time, I need things that are going to give me a negative 7 in the middle with 30. So what would they be? So factors of 30x squared that give me a negative 7. Negative 10x times 3x, or a negative 10x plus 3x. Replace my middles, 2x squared minus 10x plus 3x minus 15. Group in my 2's. Can pull out a 2 in the beginning and an x. Leaves me with x minus 5. Second one, I can only pull out a 3, and that leaves me with x minus 5. So my two factors are x minus 5 and 2x plus 3. Then move over to the second one. I can probably just factor that top one. So what does it factor to? Factors of 4 that add to 4. 2 and 2. And then I need to do the same thing with my bottom piece here. So 2x times 6 is 12x squared. And I need factors that give me 7x. So what would they be? Factors that give me 7x. 4 and 3, yep, 4x and 3x. So 4x plus 3x. Replace my middle. 2x squared plus 4x plus 3x plus 6. Group in 2's. And I can pull out a 2 and an x. Leaves me with x plus 2. Here I can pull out a 3. Leaves me with x plus 2. So my factors are x plus 2 and 2x plus 3. All right, we got it factored. So now we just have to go back through and cancel. So x plus 2's cancel. Another x plus 2 cancels. And then 2x plus 3 cancels. And so what am I left with? I'm left with x minus 5. And so that's all that's left for that one. So that's all 6 equals is x minus 5. Okay. All right, that was a division or a multiplication. And so we did a division, we did a multiplication, and then we've got 2 additions in here. So what do you think with those 2? Which one do you think we should do? First one or the second one? I'll probably do 8. We'll take a peek at it. 8 is 7x minus 2 plus 8x minus 5 all over x squared minus 4x plus 4. So I still need to factor it and come up with what my values are. This one doesn't need to be factored, but this one does. And it becomes x and x, a positive 4 that gives me a negative 4 in the center. What 2 would I have? Negative 2 and a negative 2. So then, because it's addition, I need an LCD, or at least common denominator. So if you remember from way back when, back in August, I think we were working on this stuff, I take this and always take whatever is in your first denominator, then compare it to your second one to see what you're missing. I've got one x minus 2, but I need a second x minus 2 to make it a common denominator. Okay? So then we use that for my denominator. And I can't get rid of denominators at this point because there is no equals with this. Okay, so I don't have an equals, so I can't get rid of anything. So all I need to do is compare it. So what would I still need? So 7 would still need to get multiplied by an x, yep, x minus 2. And 8x minus 5, does it get multiplied by anything? Nope, because both are represented in my denominator. So my answer to this is 7x minus 14 plus 8x minus 5 all over x minus 2 and x minus 2. But then I'm not finished because I have to combine like terms. So 7x and 8x is 15x. Negative 14 and a negative 5 is a negative 19 all over x minus 2 and x minus 2. So that becomes my denominator for that. And that becomes my answer for number 8. So 15x minus 19 all over x minus 2 and x minus 2. Okay. So you should be able to do number 7 now, I think. Hopefully that will work out. A subtraction, this one is all worked out already because the denominators match. So all I need to do is do my subtraction on the top, which means everything to the right of the subtraction needs to change. So negative 1 times the negative, or times the 3x is a negative 3x. Negative 1 times 4 is negative 4 all over x minus 7. So then x and 3x is a negative 2x. 2 and a negative 4 is a negative 2 all over x minus 7. And you could factor the top, but it's not going to help me. It won't cancel anything out. I could pull out a negative 2 and hit x plus 1 over x minus 7, but it's not going to help me because I can't cancel anything with that one. So that's not of much help. Okay, so 10 is complex, and you just invert the bottom one and cancel what stuff you can cancel with that one. So I guess we have room in here to write it. X plus 3 all over 2x times, and invert the bottom because it's really this bar as a division, 5x minus 4. So really the only thing it cancels is the 2 and the 6 and the x squared, and that's it. So my answer is 3x times x plus 3 all over 5x minus 4, because I can't do anything else with that one and making it work. Any other ones on that page? For those of you that have been working on this, anything else that we need to take a look at? Okay, then let's go to the back page. So page 2. Page 2 is more of the same kind of thing. So we'll have, you can count on certain things, of course, being on this exam. So again, 5 questions from chapter 7. So these are still chapter 7 things when we look at those. Complex fractions. Let's take a look at 12, because 12 seems to have more stuff in it, and you'll be able to, after we do 12, you'll probably be able to pick up and do 11. So 12 is 4 over x minus 8 over x squared all over 3x minus 12 over x cubed. So that's my 12. Now we did it 2 ways. There was method 1, which was working with the top part and solving it, then working with the bottom part and solving it, then doing your division. So that's method 1. Method 2 was where we found a common denominator for the whole thing. And we worked that out. And once we found a common denominator of the whole thing, the denominators disappeared. And so all we were left was what we had in our numerators, and then we just had to reduce it. So I'm trying to remember back. I think a lot of you, I think some of you like method 2 and some like method 1. So I don't know, which way would you want to see this one? Both ways? One way? Your choice. Do it both ways? Okay. So method 1. Method 1, I'm going to work just with the top. So its common denominator is going to be x squared, because I have an x and an x squared. So what would I have to multiply 4 by? I've got an x, so I'd have to multiply 4 by an x. 8 will not get multiplied by anything, okay, because it's already got a common denominator. We good there? Okay. Then I would do the exact same thing to the bottom, and its common denominator is going to be x cubed. So what would 3 get multiplied by? 3 gets multiplied by x squared. The 8 doesn't get multiplied, or the 12 doesn't get multiplied by anything because it just simply is what it is, okay? So then my last step is to finish out the division, which means I need to invert my second one, and then I need to cancel anything I can cancel. The x squareds will cancel. So that leaves me with just an x. This needs to factor, and this needs to factor. Oh, 3x squared. Yep, thank you. Yep, 3x squared is on the bottom. So I can factor out a 4 out of here. Leaves me with x minus 2. We good there? Here, I can factor out a 3. Leaves me with x squared minus 4. But that still can factor to 3 times x minus 2 and x plus 2. We okay with that part? So then x minus 2's cancel. So my final answer with this one is simply going to be 4x, that's all that's left in the top, all over 3x plus 2. All right, so that would be my solution to this one. That's method 1. So method 1, I got a lot involved because I got to get all these common denominators for everything. So then method 2, let me get a different colored pen so we know that blue was associated with method 1. Method 2, we'll do green. Method 2, we get an LCD of all denominators. So x, x squared, x, and x cubed. So my LCD is x cubed. So then you multiply everything in here by an x cubed. So x by x cubed gives me an x squared, so I have 4x squared. X squared and x cubed leaves me with a negative 8x. We good there? X squared and x cubed is an x left over times that 8. And then I do the exact same thing to the bottom. X cubed and x leaves me with 3x squared. And then x cubed and x cubed, that doesn't change. So it leaves me with 12. Okay, so a little less work with method 2. Because method 2, I can get rid of all my denominators. So now all I need to do is factor these pieces. So I take out a 4 and an x. Leaves me with x minus 2. The bottom, pull out a 3. Leaves me with x squared minus 4. Or I get x minus 2 and x plus 2. And then I get the exact same answer because my x minus 2's cancel out. So I have 4x all over 3 times x plus 2. Okay, so you got a choice. Whichever one you want to use and want to come up with for those. So that is your methods with that one. Okay. Questions on complex fractions? And that goes with 11 as well. So my answer to this piece, I'll just stick it in here so we know that's what we had did before, is that one. Okay. All right. And then 13, 14, and 15 are dealing with taking these and setting them equal. So now they're no longer an expression, they're now an equation. And so our equation that we happen to have is that we need to take care of these guys and solve them as well. Still, you need common denominator. Notice how it says restrictions, whether we have any restrictions. That means looking at your denominator. So if any of these denominators became 0, I would have a problem. This one has no restrictions. Notice there's no x's or variables in it, so there's no restrictions there. And then this next one has no restrictions. This one has restrictions. So we're going to go through and work out number 15, because that one ends up being your longer one of the group that's in there. Get my papers back together. So 15 is x over x plus 4. So some of this coming back, once you start thinking about it, hopefully, it's coming back to you of what we happen to have had with this. So to find my restrictions, which is statement 1, I need to factor this piece. So what would it factor to? Factors of 8 that add to 6. Plus 4, plus 2. So now my restrictions are taking each piece of the denominator and setting it equal to 0. So x plus 4 equals 0. So x can never, ever equal a negative 4. This has already got it in there, so I don't need to do it again. I've got x plus 2. And I minus 2, so x can never, ever equal a negative 2. And this is the same, so I don't need to do it twice. So in step 1, that's my restrictions. So my restrictions, if they asked, would be negative 4 comma negative 2. So I would put those in as restrictions. Okay. And then continuing, it says solve the equation and simplify your answer. Write your solution in either integer or simplified fractions. If there's no solution, state so. So now that I have these all factored, in step 2, I need an LCD because now we have an equals, and that equals means I can get rid of my pieces in there. So I can get rid of all of the pieces of information that I happen to have had in there. So if I stick this in, what's my LCD? Well, the first equation, I'm going to take an x plus 4. If I look at the second term in my equation, I'm going to need from it what? An x plus 4, but I need a x plus 2. And x plus 2 at the tail end is represented in there, so that becomes my LCD. So this becomes my LCD. So now I want to take this thing and multiply it by every piece that's in here. So if I take this and multiply it by x plus 4 and x plus 2, my denominators are going to disappear. So x plus 4 and x plus 4 cancel. So I'm left with x times x plus 2. We good there? 2x over this, it factored to x plus 4 and x plus 2, so I don't need to multiply 2x by anything. And then finally, x plus 2, and my x plus 2 cancels, so 1 gets multiplied by x plus 4. So we good? Okay. Then multiply it out. X times x is x squared. X times 2 is 2x. Plus 2x equals 1 times x is x. 1 times 4 is 4. So I have x squared plus 4x is equal to x plus 4. Move everything over because now it's become a quadratic. And if you remember when we did quadratic equations, we could factor them, or we could use a quadratic formula on it. So you could use quadratic, but this thing factors pretty easy. So factors of a negative 4 equal a positive 3. So what would they be? Perfect. X plus 4 and x minus 1. So I take it and solve it. And when I solve this thing, I move a 4 over. And over here, I add 1. So what have I found? Well, I found 2 answers. I could type both answers in, but unfortunately I can't, because one of these, this x minus 4, was my restriction up here. So I can never use x minus 4. The only thing I can use is x equals 1. So double check your restrictions and make sure that you're careful with that. So x can never equal a negative 4, and x can never equal a negative 2, and so therefore my solution is x equals 1 when I do that one. Okay? Yes? Maybe? All right. 16 is a story problem, so let's take a peek at it and see if we can get it figured. It says the distance that a free-falling object falls is directly proportional. Oh, okay, we got to remember what these guys mean. Directly proportional. we had three things that we did when we did that part. We had directly. And what did directly mean? Reaching way back. Directly means to multiply. And in all of these, because they are variations, we are going to multiply k by some letter, whatever that letter happens to be. Then we had inversely. And inversely meant what? This one means multiply. Inversely meant invert, divide, yep. And so that meant k was divided by some letter. And the last one was jointly. And jointly meant multiple multiplications. And multiple multiplications meant that we had k times x times y. K is our constant term, so we always have a constant value that's part of that. Okay, so let's keep reading. So I heard that directly proportional, so I know it's a multiplication to the square of the time it falls. So the distance is equal to k times the time squared before it hits the ground. So if an object fell 55 feet, so what's 55 feet? We kind of broke these apart. If you remember, we highlighted and came up with greens and pinks and yellows with some of this stuff. So it fell 55, so that's my distance in 3 seconds. So that's my square, but I got to find k. How far will it have fallen at the end of 9 seconds? So once I find k, I'm going to replace t with 9 and calculate a new distance that it has fallen. So I have 55 equals 9k divide by 9, and I get that on my calculator. So I'm going to take my calculator, divide by 9, the 55. And leave that on your calculator, because k becomes 6.111 forever and ever and ever. Okay? Then go back and find my new distance. So I'm going to take what's on my calculator, so 6.111 times 9 squared to get my new distance. So leave that on there, times it by 9 squared. And we find out that it will have fallen 495 feet in 9 seconds. Okay, so its speed increases. It's going faster. And that's, again, it makes a parabola shape because of the square that's in here. And that's why it shoots up in the one direction. And we can't have negatives, so our parabola is one-sided because we can't have any negative seconds in there. Okay, what do you think? Yes? Okay. So we'll circle 16 because that's another one that's done. Pardon? Oh, it's going to go that way? There you go. Now you got it? Sorry, I was kind of getting off the screen there, I guess. Okay. Oh, so page 1 and page 2 are out of the way. And then there's some more. I'm going to leave these directly's for you. There's a directly. There's an inversely. So y varies directly as the square root of x. So we'll just put this part in here. Oops, get down here where you can see it. We'll just put the y equals k times the square root of x. Second one, inversely in 18, y is equal to k over x squared. Okay, and then you just plug in your numbers to end up coming up with what your solution would be. I think I'm going to leave those for you too. Okay. All right. Then chapter 8. Chapter 8, we good with 7, you think? Yeah, maybe? Okay. Again, 5 questions out of chapter 7. So we've got adding, subtracting, multiplying, dividing. We had inversely stuff, and we had the quadratic ones where you had to end up solving for stuff with our setting them equal to each side and coming up and getting rid of your denominator. So you got some of that type of stuff in there. Chapter 8, we used your calculator a lot towards the end of Chapter 8 because we use matrices. You can use your matrices thing on your calculator. So we're not going to go back through and do it using the elimination method where you eliminated a variable, or we use substitution with those. So we can keep working on what we got to do with that stuff. 19 is simply asking, are these the solution to this system of equations? So basically it's replacing x with 2 and y with 2 and seeing whether it makes our statement true. And we know right off the bat it's going to be no, because as soon as you look at the bottom one, 2 goes in for x, I get 10. 2 goes in for y, I get 8. 10 and 8 are not equal to each other. So we know it's a no, that one doesn't work. The other one, you'd plug in your numbers, because if it doesn't work for one, it doesn't work for the whole thing. So you would end up finding out what that would end up being with those. Number 20 in here is write each equation in a slope-intercept form and graph each equation. Then indicate whether the system is consistent, meaning it only has one solution, inconsistent, meaning that it has no solutions, or dependent, meaning that it's identical to each other. So if I take this equation, I think we better work through 20 so you have an idea of what's going on with that one. So in 20, let me get it all written down here on my paper. Now I'm going to put the other one next to it. We'll do it in green so that we have two different colors going on here. What was that? Inconsistent meant no solutions. Yes. Okay. These say to find their slopes and find their intercepts. So we're going to end up doing that with each. So the first one, I need a common denominator. So I can clear out my denominators first. So it's going to be 9. 9 and 9 cancel. So I get negative 10x. 3 and 9 leaves me a 3. So I have 3y. And 9 and 9 cancel. So I get a negative 1. To get it in slope-intercept form, that needs to be, it's in y equals mx plus b format. So we need to get it in that situation. So I'm going to add 10x to both sides. Divide by 3. So I find y is equal to 10/3 x minus 1/3. We good there? We first got rid of our denominators. Then I moved my 10x over. Then I divided each piece by 3 to get my pieces out of this. So my slope is 10/3. My intercept is 0, negative 1/3. Okay, so far? Okay. Now, if this next one comes out to be exactly the same as this one, then we have where we have dependent, because they're going to be identical to each other. So let's see what we get. So 3, 2, and 6. My common denominator is 6. 3 goes into 6 twice. 2 times a negative 5 is a negative 10x. 2 goes into 6 3. 3 times 1 is 3y. And 6 goes into 6 once, gives me a negative 1. So would I have to even go any farther? No. So they are considered to be dependent, because this is going to work out to be exactly like this one. Okay. So what's our questions that they're asking us? So indicate, so for the consistent system, enter the solution as an ordered pair. So they break it apart and you do one piece at one time with these. Your exam will have it broken apart like this as well. So in here we would end up fitting in 10, 2/3 x, over here a negative 1/3, and for the second one, 10/3 and negative 1/3. And it was said to have had infinite number of solutions, or it is considered to be dependent. So, and if we graphed it, it would be identical to each other. So the graph, once you put this in, it'll pop up over here, okay? And you'll start to see that they're over top of each other, and so we know that they match, okay? Right with that one or not? Okay, I'll circle 20 then, so we know we did that one. And these next two are exactly the same. They're asking you to do the same type of stuff. Okay, so I think you're good there? Okay. And page 5, those that are working on this page, anything on that page that we need to take a look at? So once again, an ordered pair, we did one like that, so you can plug those in. This one's also an ordered pair, so I think you're good there. Again, 3 types of problems, so that means that one of these will be on your exam, okay? That you have to determine whether it's a correct solution or not. And then we get into these story problems and setting up equations based on those. So let's see what we can do with setting up one of these. So let's just look at, number 25. We'll see what happens with 25. It says Steve and Kevin live 690 miles apart. They start at the same time and travel towards each other. Steve's speed is 6 miles per hour greater than Kevin's. If they meet in 5 hours, find their speeds. So we're in chapter 8. Chapter 8 meant we could use 2 variables. So we can end up coming up with 2 pieces of information in here of what we happen to have. So what kinds of equations could we use? So we know they're 690 miles apart, right? So 25, so we could have one equation be x. Well, let's assign them decent letters here so we know who's who. Steve, we're going to say is S. And Kevin, we're going to say is K. So if we give them letters that mean something, when we're all done, we'll have what we need for an answer with those. So, Kevin and Steve are 690 miles apart. So Steve plus Kevin equals 690. We good there? That's the easy one. The second one is their distance, or their distance equals rate times time. So what do we know? Steve's speed, so Steve's speed is 6 miles per hour greater than Kevin's. So what does that mean? So Steve is Kevin plus 6 for his speed. But what we don't have in here is 5 hours, because distance equals rate times time. So we need to get that 5 hours in there. So where should we put the 5 hours in there? So our 5 hours could go at 5s plus or equals 5 times k plus 6. And so we would get our 5 hours in there at that point. So we have to have our speed in there, and we have to have our time. And so each of these distances are these going to be equal to each other though? What do you think? Will those be equal to each other? The way I've written it. 5 hours at Steve's speed would be equal to Kevin's speed plus 6. Should be exactly the same, okay? And so then, if we use our calculators to solve these, we got to get this so that S's and K's are all on one side and numbers are all on the other. So 5S equals 5K plus 30. So if I minus 5K from each side, I get 5S minus 5K is equal to 30. And so then I have now two equations. So I have S plus K equals 690, and I have 5S minus 5K is equal to 30. So then I can use my calculator. Anybody remember how to do that on our calculator? We had matrices set up in our calculators. Been a while since we did that. Matrices are under matrix above your x to the negative 1. So I'm going to go second, matrix. We should have still in our calculator set up the two different matrices. What size is this one? 2 by 3. So go over to edit, select the 2 by 3, go down and enter the numbers that are in front of each of these. So I'm going to put in a 1, enter 1, enter 690. Enter. Then it's 5, enter, but this is a negative 5, so minus 5, negative 5. Put a negative 5, enter, and then we're going to put in 30, enter. And so I've got it in there. Okay, now where? Always before you hit anywhere else, double check it and make sure it's in there, right? 1, 5, 1, negative 5, 690, 30. And then second quit. Now where? Second matrix. Then where? To math. Yep. Down to B. You can also up arrow to B. Get you there a little bit shorter. B. Then where? Back to matrix. Second matrix. Stick in the names of the one you want. Close it. Hit enter. And there's our answers. Spot. Do those answers sound right? So what were we to solve? Better go back here and look. We have just found how far they traveled, but did we find out what their speeds happen to be? We got one at 348 and one at 342. Not our speeds, right? But what do we know about each of those numbers? If we take them and divide them by 5, we will come up with what our values would be. So 348 divided by 5 equals 69.8. So that is Steve's speed. And then we got to find Kevin's. Kevin's traveling 6 miles slower, so 342 divided by 5 will give me, oops, we still don't have the right answer. So what did I do wrong? I put, what was it? On Steve's, I put was back here in the very beginning part. Okay, so that's not right, is it? Because there's supposed to be only 6 miles of difference in between each other. And I've got 6 miles difference in here between 8 and 42, but I don't have my times calculated out. And the reason is because the 5 needs to go basically right here. So I need 5s plus 5k is equal to 690. So I get their speed in there and not put my 5 in the other spot. So s equals k plus 6. That's what my problem was with this one. So again, leading you the wrong direction with this one. So let's go back into our matrices again. So second matrix, over to edit, down to 2, and over. So this time I'm going to put 5, enter, 5, enter, 690, enter. And down at the bottom, the k needs to go over, so s minus k equals 6. So 1, enter, negative 1, enter 6, enter. Now, let's see what happens. So double check, 5, 1, 5, negative 1, 696. So second quit, second matrix, over to math, up to B or down to B. and then second matrix, and put in names, close it in parentheses. Now we get what we wanted to have. Okay, so my answers really are 72 and 66. So now we've got our speeds going the right way. So Steve is at 60 or 72 miles per hour, and Kevin is at 66 miles per hour, right? But again, it's playing around with these and getting an idea. Does my answers sound realistic, or do they not sound realistic? So you got to be careful with that and make sure you get your pieces where they're supposed to be. So Steve, putting my answers in here, 72, and Kevin is 66. Okay. So I don't know, let's take a look at 28. 28 says the sum of two numbers is 42, so x plus y equals 42. The sum of the smaller and 4 times the larger, so x plus 4 times y is going to equal 14. And then you can put that into your matrices and see what happens with it. Okay. Which one? Oh, 147. Thank you. Yep. Okay, and then you stick those on your calculator and go from there. Oh, on your calculator? Yeah. We did it more when we had 3 than we did with 2. So let's just put this one in here. Okay, so I get second matrix. Then I want to go over to edit. And if you've got a 2 by 3, which means I have 3 things and 2 equations, I use the top one. Go over, and I got to put it in. So 1, enter, 1, enter, 42. So you're good with this part? Then it's 1, enter, 4, enter, 147, enter. And then double check it. So I've got 1 and 1. I have 1 and 4 and 42 and 147. Because it will solve whatever you put in there. So second quit. So then we go second matrix, J. Over to math. At the very top, you'll have names, math, and edit. You go over to names. And down, I'll do it the correct way, down to B, and hit enter. And this will solve your matrix for you. Then it's back. Are you up to that point? Okay. Get caught up on writing. And then it's second matrix. Stay on names, and we put it in matrix A. So we want to hit enter. Close it in a parenthesis, and then hit enter one more time, and it will give you your answers. Okay, so number 1 is 7, and number 2 is 35. Okay, you good now? Oh, what part? You're still back at the math part, or where? Were you figuring it out? Jay, is that where you're at? So that second matrix. Oh, you have your paper? Okay. Yeah, yeah. Because there was a handout at that time that went through what you had to do with these. But if you go to math, down to B, and B is where it will figure out your matrix for you. Then second matrix, and then because it's in A, I just hit enter and close it in parentheses and hit enter one more time, and it works out my answer. Okay, yeah. All right, think you can do the rest of those? Hopefully. Over the weekend, if you run across any of these that are giving you trouble, all you got to do is say, I'm having problems with on the review packet problem 18. And just send that to me because I'll be on probably over the weekend. So on checking my online groups. And so then I can just put that answer in for you and show you how to do it with what you had to do. Okay. Then we get into 3x3 matrix, same type of thing as far as putting those in to your problems and what you have to do with those pieces. So want to run through one of those? So let's run through 33. Same process, just picking a different matrix on your calculator and entering more numbers. So second matrix, over to edit. But this time it's a 3 equation by 4 pieces in each equation. So I want to go on to the B. Enter each part. So 2, enter. 6, enter. -7, enter. -3, enter. -5, enter. 3, enter. -5, enter. -6, enter. Then 6, enter. -2, enter. 4, enter. 6, enter. And double check it. Again, it will give you an answer for anything you put in. So if you don't take the time to go back and check it and you get your answer wrong, it's going to cost you about 7.5 points, because that's about what each problem's worth on your final exam. So be careful. Make sure you enter stuff the way it should be. Double check things. So if I double check it, -3, -6, 6, -7, -5, 4, 6, 3, -2, and over arrow to get to the first one, 2, -5, 6. I know my calculator will calculate out the right answer for this one. Okay, so double, triple, 4 times, quadruple, check. Okay, if you take the time on that, you'll have a better chance on getting all your points out of your question. So now we're going to go second matrix, over to math, down to B, hit enter. Second matrix again, go to names, and I want B because that's where I put it in at. Close it with a parenthesis, hit enter, and it gives me an answer. Okay, so this answer is kind of screwy looking. Normally, what I get for answers is I get 1, 0, 0, 0, 1, 0, 1, 1, or 0, 0, 1, and I got some weird, funky stuff going on here. So the reason it's weird and funky is you look at that bottom row, notice it's all zeros. What does that mean? That bottom row is all zeros. Very important. Hint, hint, hint. Gigantic hint. If it's all zeros across the bottom, it means I have no solutions, many solutions, infinitely many solutions. Which do I have? Infinitely many solutions. Yep, so letter C is what I have. If it were no solutions, I would have 0, 0, 0, some number in the last position. So that would hold a 6 or a 5 or a whatever, but it would be zeros all across the bottom. Or if it is one solution, I will have 1, 0, 0, 0, 1, 0, 0, 0, 1, and then numbers on the side. So that means I have one solution. So be careful with those and figure out what in the world's happening to them. Okay, so you have infinitely many solutions to that one. So be careful with those. The next two are, of course, story problems. The theater, you guys need a break? Yeah? Okay. Why don't you take a break and we'll be back in about 5 minutes. So we can get through this stuff, we got to get back at it. So I think that was about 5 minutes, maybe. So let's set up this story problem that's in here, the one that has the balconies and the Broadway play that we have. So if we read through this, it says, use a system of equations to solve the following problem. It says a local theater has 3 types of seating for Broadway plays. They have a main floor, we're going to label that M. They have a balcony, we're going to label that B. And the mezzanine, which is another M, but we can put a Z with that one so that we at least give it a different name connected to it. So the main floor tickets are $57. The balcony tickets are $36. The mezzanine tickets are $27. One particular night, the sales totaled this amount. So sales means I have each of these pieces. So I have 57M plus 36B plus 27Z is equal to the total money they brought in that night. We good there? So that's the first one. Reading on says there were 369 more main floor tickets sold than balcony and mezzanine combined. So what had the largest sales in here? There were 369 more main floor tickets sold than balcony and mezzanine combined. So that means the main floor is equal to 369 plus the balcony plus the mezzanine. We good with that part? No? That's fine. It's the same. It means the same thing. Yep. Yep, means exactly the same thing. The comment she'd made, she had the 369 minus over here and then the balcony and the mezzanine on the other side, which is fine. We still got to adjust this to put it on our calculator anyway. And when we get it all adjusted, Rose, it's going to look, they'll be both the same. Okay? Yeah, because you're going to move the 369 over, which makes it positive, and you're going to move the balcony and the mezzanine over to the other side, which makes those negative. So we'll still be good. Then it says the number of balcony tickets sold is 46 more than 4 times the number of mezzanine. So the number of balcony tickets sold was 46 more than 4 times the mezzanine. Okay? We good or not good? Okay. Then we got to put this and get it so that it's in the correct format to put on our calculators. So this first line is perfect. Okay? No change with that one. The second line, I need to get B and Z over. So the second line is going to become M minus B minus Z equals 369. Okay? And then the last one we need to adjust to, and with the mezzanine over, so B minus 4Z equals 46. But to stick it on my calculator, I need to have in here 0 of the main floor. Okay, because I have to have something holding all positions when I enter it on my calculator. So what happens? So let's go and let me clear my screen here. And we're going to put this stuff into my calculator. So we're going to go second matrix, over to edit, down to 2 because I want 3 by 4. Hit enter. Go beyond the 3 times 4 or 3 by 4. And we're going to put 57. Enter. 36. Enter. 27. Enter. And 33,975. Enter. And then we're going to go to my green lines, not my blue, because they're not set up right for my calculator. 1, enter, negative 1, enter, negative 1, enter, 369, enter. And the last one is going to be 0, enter, 1, enter, negative 4, enter, 46, enter. And I'm going to double check it going the opposite way. So 33,975, yes. 369, yes. 46, yes. 27, negative 1, negative 4. 36, negative 1, positive 1. And last, 57, positive 1, and 0. So we're good there. Second, quit. Second matrix. Over to math. Down, get my B in there. And go second matrix. And go down to B, because that's the one I want to solve for. And hit enter. And this is what a normal one should look like. So if you have a normal matrix, the top line is the number of seats for my main floor, so 510. B is 0, 1, 0, 122. And last of all is the mezzanine, which is 0, 0, 1, 19. Column 1 is main floor, column 2 is balcony, column 3 is mezzanine, and that's the number of seats. Okay, so that's what we found. All right, we good? That one you think? Okay, I'll leave 35 for you. And 35 again's got our different pieces in there to work with. And the last thing that we did in this section, which takes up quite a few pages in your assignment, was to graph these things and figure out what side shaded. So again, so we're kind of looking at this and saying, okay, we got 2 by 3 matrices. We have 3 by 4 matrices. We have story problems with these. We have graphing. And so that's about your 5 questions that are on your final exam over chapter 8. Okay, so it seems like we've been taking ever in chapter 8, but that's what it takes sometimes. So when you do these, again, your final exam will be broken into parts just like this is. It's not going to be having all of it jumbled in together. So first off, we need to determine whether it's solid or dashed. If you remember these guys, it is which one? And again, it's your inequality that tells you whether it's solid or dashed. So which is it? It's solid, yes, because there is an equals that's in your inequality. So if it were just less than or greater than, it's dashed. So that's what's going to tell you that piece. Okay, so then it says what's our slope. So our slope's what's in front of x, so a negative 6 over 1. Our intercept is at the tail end, and that is a negative 9. And then what would happen with this is it would automatically go in here into Hawks, and it will graph this. So it's going to be down here at a negative 9. We're going to go the opposite of what this is, so I'm going to go up 6. Oops. And over the opposite way, 1. And so my solid line is coming in somewhat like so. Okay, then I got to decide what side's shaded, and they will label these side A and side B, and I don't know how they labeled them. I don't want to mess up your answer key in the back, but one side's going to be labeled A and one side's going to be labeled B, and you have to decide what side's shaded. To do that, you can pick a test point or know that your graph is less than, so that's going to shade below the line, not above. Or if you use a test point as 0, plug 0 in for y and 0 in here. 0 is less than or equal to a negative 9, which is false. So that means I'm not going to shade where that's at. So whatever side that is, and I don't know, I think they labeled them A to B, A here and B here, but I'm not certain, so we're going to circle A, but we'll find out what we got going. Okay, then you go to the next one. Is it solid or dashed? It is dashed in this case because I don't have an equals. the slope is 2 over 1. The intercept is 0, 3. And when you plug those in, it will graph it. So we're going to be at 3. And my slope says I'm going to go up 2 and over 1. And it's dashed. So this line's coming in like so. And then what side gets shaded. And again, if we labeled it C and D, and again, I don't know if that's for sure the way in which it was labeled originally, what side gets shaded. And again, it will walk you through these as you do those. And so since it's greater than, I shade above the line. Or test point 0 and 0. 0 is not greater than 3, so I would not shade where my test point's at. Okay, and so then it will put both graphs together. So we had this one's coming in like so. I know these aren't quite right, but I want to try to get to something else of saving some time in here. 1, 2, 3 over 1. Oops. Up 2 and over 1. The blue line was shaded here. The green line was shaded here. So what side has double shading in it? So then they will label all these sides as well. And so the double shaded was over here. So you'll watch whatever letter is in that location. They usually come out kind of a ugly pinky purple color when they double shade them. So you got some ugliness in there. Okay, and so that takes up the next 3 pages of doing those. So I think we're good. What do you think? Okay, now 737, you got to solve and get it into slope-intercept form before you can work with it. So that just means solving for y. So you want to get y by itself in there. Okay, all right, so that takes care of those problems. That brings us to Chapter 9. Chapter 9 shouldn't be too awfully unfresh because we just worked with it, and then we've been using Chapter 9's material in Chapter 10 and in Chapter 11. So hopefully it's not too far off of what you got going. So 39 says simplify. So in 39, if I'm going to simplify this, I need to pull out anything I can. So remember we took 80 and we broke 80 apart. And we said it was 8 times 10, and 10 was 2 times 5, and 8 is 2 times 2 times 2. So really 80 was 2 to the 4th power. And then we had an x squared and a y to the 4th. And because it's a square root, every time I see a combination of 2's, I can pull them out of my exponents. So 2 goes into 4 twice, so I can pull out 2 squared, or 4. Leaving a 5. Whoops, I left my 5 out. X squared, 2 goes into 2 once, so I pull out an x. 2 goes into 4 twice, so I pull out a y squared, and that's what that becomes. Okay, so you've got some reducing stuff to do there with those. Then 41. So in 41, you've got 2 radical pieces in here. So I can break it apart into 2 separate pieces. And take the square roots of each piece. So 75 is 3 times 5 squared, x to the 4th. So I can't pull out the 3. I can pull out a 5, and I can pull out an x squared. The bottom, 100's a perfect square, so I can pull out 10. Y to the 8, I can pull out a y to the 4th. And then my 5 and my 10 cancel. So my true answer to this one is x squared, the square root of 3, all over 2y to the 4th. So it's a matter of reducing those things and coming up with what their solutions might be within those. Okay. Same thing with 43, it just breaks it apart. This one, same thing. You can combine like terms that are matching. So this comes out to be a negative 10, the square root of 5, minus 4, the square root of x. And I can't put that with it because they don't match. So there's no matching going on there. And then 44, cube roots. So I'm looking for things of cubes that I can pull out. So is anything cubed pull out of there? So 8 is 2 cubed. X to the 14th, y to the 23rd. Then at the very last one, I can pull out also the 2 out of there. So what does this factor to? So I'm looking for everything that has 3's in it that I can pull out. So in the first one, I can pull out a 2. And maybe I better do this one on a separate sheet of paper because I'm going to run out of room in my little space on there. So 44, cube root of 8, x to the 14th, y to the 25th, 23rd, plus cube root of x to the 14th, y to the 23rd, minus the cube root of 8x to the 13th, y to the 5th. So I better do it on here. So I could pull out a 2. X3 goes into 14 4 times, so I can pull an x to the 4th. 12 from 14 leaves an x squared underneath. Y to the 23rd, 3 goes in there 7, and leaves a y squared. Same thing over here, pull out an x to the 4th and a y to the 7th. It's the same identical piece underneath. Questions with this? Are we good? Okay. And then finally the last one, I can pull out a 2. I can pull out an x to the 4th, and it's going to leave an x underneath the radical. And 5, 3 goes into 5 once, and it leaves a y squared underneath the radical. So then what can get put together? Well, the only things that match are the first 2. So 2 plus 1 is 3, x to the 4th, y to the 7th, the cube root of x squared, y squared. And the last piece, I can't do anything with it. Okay, so that piece, I can't do anything to it. What do you think on those? Been a while since we did chapter 9 also. So that's what happens to 44. And then the rest of them are rationalize the denominator. Remember we had conjugates. If we've got this piece in there, so in 45, I would multiply the bottom by the cube or the square root of 3 plus 5, and the top also by that. And then you FOIL in here. So square root of 7 times square root of 3 is the square root of 21. Square root of 7 times 5 is plus 5, the square root of 7. 3 times the square root of 3 is a negative 3, the square root of 3. And last, negative 3 times 5 is a negative 15. But what happens to my denominator when I rationalize it is it disappears. Square root of 3 times square root of 3 becomes 3. Negative 5 times a positive 5 becomes a negative 25. And so then my final answer to that whole thing is the top with the bottom piece added together, or a negative 22. But I can't leave it that way because I can't have a negative in my denominator. So what that's going to do is it's going to go back through and change all of my signs in my top part. Okay, so now it's going to be a negative 21 minus 5, the square root of 7, minus, or plus 3, the square root of 3, minus 15. So you shall watch those signs so they change. All right, questions with this part? What do you think? Think you can handle those? This one, you need to rationalize the denominator here too, but we better take a peek at 46. Because to rationalize my denominator, if I take the square root of 16ab, I can pull out a 4. Leaves me the square root of ab. So what would I multiply top and bottom by to make that radical go away? So I'd multiply the bottom by the square root of ab and the top by the square root of ab. So down here in the bottom, we'll have 4, the square root of ab, And on top, I can pull out an 8, the square root of AB. And I'm going to multiply the bottom by square root of AB and the top by square root of AB. And I'll end up with 8 and 4 cancel, leaves me 2. Square root of AB times square root of AB is just going to be AB. And also on the bottom is going to be AB. So the AB's cancel. And so the only thing you're left with is just 2 for that whole thing. Okay. All right. So how you feel about this review so far? So far, so good. Hopefully, you can pull it all together for your final exam. But we'll talk about that after we get done doing all of our pieces in here. Another rationalizing denominator. We just did one of those, so I think you're okay there. This one is the radical equations. Was writing that piece out. Square roots on both sides. So all that simply means is I need to square both sides. And when I square both sides, the square root disappears. So on this one, number 49, I'll put that over here too. 49 is the square root of a negative 1 minus 6v is equal to the square root of a negative 4v plus 5. Square both sides. And I find out negative 1 minus 6v is equal to negative 4v plus 5. Move my 6v over because I need to solve for v. Move my 5 over. Divide by 2. And I find out that v is equal to a negative 3. And as long as that does not make the radicals ever become negative under here, because we can't have those. So if that doesn't, then we're good to go. So negative 6 times a negative 3, we're good there. Negative 4 times a negative 3, we're good there. So negative 3 is my answer to that one. Okay. This one, when you square each side in 51, you need to FOIL that side. Don't just write t squared plus 16. It's going to be t squared plus 8t plus 16. So make sure you FOIL that piece. And then these are our i's, getting into imaginary numbers with those and making sure you multiply that stuff together. So let's just do 54. So you at least get one I1 in here. So 4 minus I the square root of 5 times 4 plus I the square root of 5. So if I multiply it, 4 times 4 is 16. 4 times that is a plus 4I the square root of 5. Negative 4I the square root of 5. And last, a negative I times an I is a negative I squared. Square root of 5 times square root of 5 is just simply 5. So this becomes 16. These guys cancel. And I squared goes to negative 1, so I really have a plus 5. So this whole thing simply becomes 21 when you're done with it. So that's 54. Okay. Chapter 10 should be not too unfamiliar. It hasn't been that long ago that we did chapter 10. So hopefully we can remember what stuff we ended up doing with those and coming up with what our solutions would be. 55, 56, and 57 all match. It says solving a quadratic equation using the definition of square roots and radical forms. So what that means is we're going to take square root of each side of this. So I'm left with 7x plus 5 is equal to the square root of 48. But when I take the square root, that's where I get my plus minus at. And 48 breaks down to take out a 16, so I can take out a 4, leaves the square root of 3, move my 5 over, and last of all, divide by 7, so x is equal to negative 5 plus or minus the square root of 3 all over 7. And so that becomes my solution to this one. Okay. So square roots each side, that's same thing here, same thing there, and come and work that stuff out and see what you get within those. So that was 55. So it's an example of one of them. So we've covered a lot of stuff when you really start thinking about it. Pardon? Oh, it's got to be there. I left it off. Thank you for saying that. It's right there. Should be right in there because it can't cancel. Pardon? Yeah, you could figure this out for an answer, but you can get by with that because you'd take plus a negative 5 plus for the square root of 3. So that's what you're asking. So really x would equal a negative 5 plus for the square root of 3 over 7, or negative 5 minus for the square root of 3 over 7. Yeah, that's what you meant about dividing it out into two parts. Yeah. 58, 59 are using the quadratic equation. And it says completing the square. So let's take a look at number 58 and see if we can complete the square with it. So x squared plus 3x minus 14 equals 0. So in review of completing the square, we need to add 14 to both sides. Then we take half of the middle, put it down below, but then up above, we're going to square it and add it to both sides. 3 squared is 9, 2 squared is 4. So 14 into fourths is 56 fourths plus 9 is 65 fourths. Oops. Take the square roots of each side. Can take the square root of 4, so we want to put it over 2. Cannot do anything with 65. It doesn't break apart into anything else. Wait a minute, does it? No, it doesn't break into anything else. Because 5 will go into it, and that gives you 13, so that's not going to help us out. So then move your 3 halves over. And your two answers would be x could equal a negative 3 plus the square root of 65 over 2, or negative 3 minus the square root of 65 over 2. So we got it to work out in that format. Okay. All right, with completing the square. So somewhere there will be a completing the square in your final exam as well. So back page of that. Another completing the square, so we're going to skip that one. Quadratic formula. What is our quadratic formula? Negative b plus or minus, yes? Uh-huh. Mm-hmm. Yep. Perfect. Yep, we got it. Okay. And then all I need to do is plug in my numbers, and I think we did tons of those, so I think you're good with that, aren't you? Okay. I kind of thought so. If you got like number 62, you need to move the negative 1 over before you plug in your numbers, because it has to be set equal to 0 for that. So you want to make sure you do that. The discriminant, we talked about that. That is this piece under here, this a squared or b squared minus 4ac, and that told us a lot of information. If this b squared minus 4ac came out to be a positive number, you have two solutions, and they're real solutions. If it came out to be negative, you had two imaginary. And if it came out to be 0, there was only one solution. So you only get one solution with that one, okay, with that part. And so that kind of gave us a good indication of what we would have with that, okay. Then 64, we had pieces of information on what this graph meant to us. What tells me whether it goes upward or downward? Which number in this whole thing would tell me whether it went upward or downward? The 2. And because it's positive, it's going to go upward. The 2 also, in comparison to this one, is this one narrower or is it going to be wider than the 3rd? So which way did it go? The bigger the number, the narrower, or was it the smaller the number, the narrower? Yep, bigger the number, the narrower. So what this would say is this one is narrower than that one. So we would circle this piece, okay? And then the next one is determine 2 additional points. If you put this on your calculator, you have a whole ton of points in there. So if we go to our y equals, clear out what I've got in there, and I put 2 parentheses x minus 4 parentheses squared, and I go second to my table, I get a ton of points, okay? So I have a whole gob of different things I can select down here. And so you might want to go down a little bit and figure out what values you have. And they're asking me if what point that starts at 2. So if I'm at 2, my answer is going to be 8 would go in my box. So I can just find that on my calculator, okay? So that piece is right there looking at you. And the next one was if it were 5, it would be at 2, okay? And it will automatically plot those points on here for you, okay? So they would be plotted in there as you do those and you put them in. And I think that's all it's asking you with that one, okay? All right. And there's 2 more in here, 65 and 66. And those both have pieces to pick out in there too. So I think you're okay. What do you think? Okay. This one, 67, is a little different because in 67 it's asking you to get it into this format. We did that by completing the square, not fully completing the square, but we get it in that format by doing that. So I guess we should work that one out too. Let me put 67 on here. So we have y equals x squared plus 2x plus 4. And if I want to get it in that format of a parenthesis x minus h squared plus k, I can get it there by completing the square. So x squared plus 2x, move my 4 over, take half of my middle, square my 1, add it to both sides. And instead of going farther and completing the square, all I need to do now is just move my 2 back. And I have it in that correct format. So I didn't have to go all the way with that thing of completing the square. But if I get it in this format, I've got it so I can get my information out of here now. And my information on 67, let me write it in here. X plus 1 squared plus 2 equals 0. I can end up finding out my vertex. What's my vertex on this one? Well, my vertex would be which combinations create a vertex. So it's negative h, k creates my vertex. So opposite of h is a negative 1, k is 2, so that's my vertex. The zeros, if you factor this, I can't factor it, so I'd have to use the quadratic on it, or just simply go through and finish my completing the square here. So if I complete my square, I'm going to have x plus 1 is equal to I, the square root of 2, plus or minus. So as soon as I get I, that means I have imaginary spot, so it never touches x. So this one, you would have to say it has no real zeros. And then graphing 2 points, put it into your calculator and pick out your points. So if I do that, I can put x squared plus 2 x plus 4, hit my table, and I've got some points in here. So negative 1, 3, and 0, 4, and I am good to go. Okay? All right. Questions with any of that? And I don't think we need to review chapter 11 because you just did that, right? I think we're probably okay with the questions that pop up in chapter 11. Usually, and be careful with that, because sometimes what happens is chapter 11 can be the one where you miss all your points. No, you just did it. Okay? So we made it through everything. So do you guys feel comfortable enough with that? Or do you want an extra day to review your final, for your final? Pardon? You want an extra day? Well, that's good for you. You agree? An extra day? No extra day? All right, we've got extra days and no extra days, extra days, no extra days. Let me get this turned off, and we'll discuss that even more. There's no sense in having that on my tape up here.